The last time I mentioned a destruction error that I had made, and we were waiting for the first power-up. If you haven't watched the part 1, you can click on the top right now. Let's get started! So the power supply of this computer is a universal Aztec. This means that on the connectors it has universal voltages, and they are plus 12 volt, plus 5 volt, COM, which is ground, and minus 12 volt. On the connector, minus 12 and plus 12 are close, and I had read plus 12 twice. Yes. So when I connected the RTX, I wired plus 12 to minus 12. Yep. Fortunately, the minus 12 goes directly to a voltage regulator, which turns it into the minus 5 for the 4116 RAM banks. More on that later. Basically, I fried the voltage regulator, excluding the RAM, because of the minus 5. I searched throughout the manual and it seems that the minus 12 goes only there and to two amplifiers for the cassette interface, U79 and U80, so since the regulator burned instantly closing the output, I didn't do too much damage. Still, I'm an impatient idiot sometimes. Knowing that, we turn on the computer for the first time and we get this. So we know that the motherboard is not working properly, but there are some positive sides. First, we have something on the screen, so the video section on the MOBO is working. We also have the vertical deflection, and this means that there is high voltages and a part of the CRT circuit is working. Vertical deflection is completely missing, so I expect to find some broken transistor in the vertical section. Just to be sure that the problem does not lie in the circuit for the cathode ray tube, I connected the video output from the motherboard to my 1084S, and in fact I get garbage on the screen, but at least I know that the vertical deflection works, even if I have not connected the pin intensity, which is why there is no vertical hold. I would say that CRT will be the next item on the agenda. Disassembled the CRT PCB, I noticed this. This capacitor and this resistance came off during shipment due to the impact of the deflection yoke with the board when the CRT broke. Both components are related to horizontal deflection, so they are not the cause of our problem. Also, the capacitor is a 5.6 UF one and my local electronics store does not have any, so I will just solder them back in their place. Removed the circuit board for further investigations, I discovered a good amount of corrosion below. Nothing to worry about, no trays were affected, however it is necessary to eliminate it to prevent it from growing and eating away traces. There is also a nice deep scratch, which has cut away a piece of the ground plane. Nothing to worry about here too, but it's good to restore connectivity. As usual, I will deal with corrosion using white vinegar. Out of curiosity, I tried to turn on the monitor after reattaching both damaged components, but almost nothing has changed. Probably I didn't have horizontal hold before, and now I do, but still no vertical deflection. Later, off camera, I armed myself with thick gloves and a ground strap to check the output of all the transistors in the vertical section with the monitor on, and I found some values that were a bit high compared to the diagram. We are talking about 10 volts more in the worst scenario, and this probably has to do with all capacitors, but it is certainly not the cause of the lack of vertical deflection. Perhaps weak capacitors would affect vertical hold, but not deflection. Probably. At this point I was lost. I could not understand what was the problem with this damn monitor. Then I had an epiphany. The deflections, both vertical and horizontal, are supplied to the tube by the yoke. I don't want to go into detail, also because I know very little about cathode ray tubes and I risk saying some stupidity, but in a truly barbaric way it can be said that the deflection yoke is nothing more than two clews of copper isolated from each other, like in a transformer, except that there is no dialogue between them. So I decided to measure in continuity between the ends of the two clues, and finally, eureka! In the part dedicated to the horizontal deflection there was continuity, while in the part of the vertical deflection it was missing, and in fact, after dismantling the yoke and inspecting it carefully, I found a broken thread. Since repairing it is a difficult operation, I decided to take it off camera. These wires are covered with varnish to make them insulated, so I had to burn the varnish layer, apply solder, cut a piece of normal wire and solder everything, and then insulate again with a heat shrink tube. Since I had the board outside the case, I decided to change the suction cap, since the old one was becoming glass, and to extend the high voltage cable, since the new tube has the anode in a different place than the old one. Then I applied epoxy resin on the repair in the yoke to make it less fragile, and I finally covered the flyback transformer with epoxy resin as its outer cover was falling apart. Now I can reassemble everything to give it a try. And finally we have an image. Both vertical hold and horizontal hold are missing, and this is because I moved the relative potentiometers while trying to understand what the problem was. Okay, now we have a stable image. Now I can tackle the -12 issue. Looking for the problem, I checked the voltage regulator 1 with the multimeter, and in fact I measured 11 volt from the input and 0 volt from the output. While waiting for the new voltage regulator, I tried a slightly punk solution. The 4116 ramps are powered by -5, +5 and +12 volt, unlike the more recent and common 4164. However, the pinout is practically the same, excluding the voltage lines. There are dozens of tutorials on how to modify RAM chips for 4164 so that they are compatible with 4116. You can see how the data input, read-write addresses and so on lines are exactly the same, just change the voltage. I followed this guide to modify a 4164 bank, and I replaced the previous 4116 bank, since now the -5 is not required. However, I was not lucky and the computer did not come back to life. From here it was only a matter of changing the burnt regulator and correctly connecting the power supply. Once the power is connected, the computer regularly boots in BASIC. However, there are some problems. The most obvious is that when I turn on the computer, some characters appears when asked for the speed of data transfer, as if they were constantly pressed. Moreover, the image on the monitor is not stable, occasionally it moves, it shrinks, therefore probably the capacitors are gone. When I press multiple keys together, strange things happen, and only a handful of keys work. At the beginning I thought that the problem with the keyboard was related to the keyboard, given the reputation of unreliability of these keyboards, so I checked the keys on the PCB in continuity and they all seems to work, so I grabbed the schematics to take a look. This keyboard works like a grid, in which there is an open circuit, and when you press a key you will provide coordinates that identify that key. Not quite so, but you get the idea. If we look closely at this column, we can see that the corresponding keys are F, N, V, the AND symbol, a quotation mark and a arrow. When I turn on the computer, there are the exact same characters, as if they were constantly pressed. Looking at the end of the diagram, we can see which are the chips that control the keyboard signals, and from here we can proceed by elimination. the abscissa axis is controlled by U34 and U35, so if we try to map the non-functioning keys, we see that F is controlled by U34, while V is controlled by U35. So I will exclude U34 and U35 because other keys under their control work fine. On the other side, on the coordinate axis, there are 3 ICs and a resistor pack. The 3 ICs are U65 and U51, which are 2X buffer, standard 4050B. This is a Motorola number, so it is slightly different. And U66, a 74LS240, which is an octal 3-state data receiver. It is unlikely that the problem is the resistor pack, so I will focus on U65 and U66, since U51 has nothing to do with that row of keys. I took them both at my local electronics store and now I'm going to change them, inserting a socket so I can test if they are not a problem. At the shop I did not find the right socket, so I took one with multiple pins, and to avoid short circuits I will remove the 2 extra pins with a needle. Out of curiosity, I want to see what happens when I turn on the computer without the 2 chips that I just removed. We no longer have the characters on the screen before, but no keys work now. Now let's try with the new chips. And in fact, it works now. We have no misplaced characters, only the prompt for loading from a cassette. Entering BASIC, the enthusiasm stopped immediately because very few keys were working and many were constantly pressed, like the Shift key. So I decided to copy the grid of the keys on my notebook and trace the non-functioning key to try to understand if there were other recurring patterns. Apparently there weren't any, so I couldn't figure out which chip was broken, so I decided to try changing all the chips on the keyboard section to determine if the problem was with the circuit or with the keyboard. At first I changed the chips of the abscissa axis, but there was no change. Later I changed the second hex buffer, the U51 off camera, I didn't even opt for it anymore, and this solved many problems, but left me with this column of keys not working. I checked everything on the motherboard, I changed all the chip in the keyboard section, but nothing worked, so I decided to test the output of this line with the oscilloscope, which corresponds to pin 4 on the connector, through all the chip in the keyboard section to see if I could get any kind of data, and I found that there was no activity on that line, not even a little. This left me quite perplexed, since the keys I measured them in continuity mode and they work. So I decided that there was a problem between the keys and the keyboard connectors. I checked in continuity between the pin 4 of the connector and the whole line of keys, and I discovered that there was continuity between the connector and some connection points on the PCB, but from the first key onwards the continuity ended, and since they are connected in parallel, a broken trace is enough to prevent the whole row from working. Looking at the PCB with a lens, I found it. a broken trace right between the first key of the column and a connection point near the connector. Now it's just a matter of installing a jumper on the broken trace. This has improved things a lot, but there are still some broken keys, such as plus, S, and 6 and 8 on the numpad, and this is a mechanical problem, because by measuring these precise keys in continuity you get nothing. For example, the 8 key on the numpad does absolutely nothing. Knowing how to hit with Chinese chopsticks helped me a lot in this case. Instead, the 7 key works. So now I have to take the broken keys apart and see what can be done about it. Okay, let's try one out of the PCB, and in continuity we have nothing, not even a little resistance. Inside the button there is a plate with 2 layers of conductive material, which when pressed in a certain point make contact. The button plunger activates a metal tab that pressed on the point, but with use the tab deforms or the plunger wears, and therefore there is not enough pressure, or between the 2 conductive material corrosion is formed, which prevents connectivity. In the case of this button, there is no corrosion, because if I press manually on the plate I get continuity. So I try to bend the tab a little to create more mechanical stress. Okay, after many and many attempts, the key works. With the other keys, however, the problem is corrosion. This is the plus key, it is completely baked. I will try to dip it in white vinegar, but I'm skeptical. Okay, it worked, and now every key works. The keyboard is fully functional, however in some parts the paint has come off, and these parts are visible from the outside, so I will try to repaint them. Okay, it's kinda sloppy work here, but I'm tired of working on this computer, also that's a really minor issue. However, it is better than it was before. Now I want to solve another monitor problem, the unstable image. After a few minutes of operation, the image starts to flicker and wobble too much. This problem is certainly due to aged electrolytics. I'm not a big fan of the recap everything you have method, but in some cases, especially in analog circuits, changing old capacitors certainly brings benefits. I found almost all the capacitors locally except for the 5.6 UF that has snapped, and this is bad because it is very ruined aesthetically, and on the capacimeter it measures a value a bit off. I have no way of measuring the ESR, but I guess it is high. It is to be changed, so for the moment I will do a partial recapping. In the future, when I change the tube with a more suitable one, I will take care of this capacitor, the broken potentiometer and the paint outside, because I want to repaint it. So there will certainly be a part 3. Returning to the monitor, the capacitors I have taken are not of high quality, but for the use I intended to make of this computer they will be fine. Also, those on the circuit board are crap, so in a certain sense they are adequate. While doing the recap, I noticed a missing capacitor. It is the C516. On the back you can see that it was certainly installed. At first I thought that the capacitor has snapped, as it happened with the other, and checking on the component list I saw that it is marked with an asterisk, as seen that it's an important component for safety, so I worried about its absence, but then I looked at the scheme and in fact the component is grayed out, which indicates a critical component for the scheme. However, it says cut if required, so I'm a bit perplexed. I searched the whole box for a stray capacitor and I found nothing. I'm starting to wonder if that wasn't one of the reasons why the computer was serviced at some point. Renewing my admission of ignorance regarding cathode ray tubes, asking around seems to be a capacitor that allows you to correct some defect east-west, so I'm not very worried. At the moment the monitor seems to work fine, so I won't do anything about it. Okay, now the circuit board is recapped, let's try it now, and wow, the recap actually made the difference. I haven't done many shots of the monitor running before, but trust me, it's a big improvement. I also managed to get a raster by increasing the brightness, which was not the case before. Since the capacitors on the power supply are the same, I think I will recap that too, considering how much the monitor has improved. I found an old RCA cable and I want to use it to build a cable to load programs into the Model 3, since mine is a diskless system, and to have audio output. We will use a single 5-DIN connector, since both data input and data output pass through here. Looking at the diagram, the wiring is not complicated. The middle pin is ground for both data input and output, the one on the left is data input and one on the right is data output. The other two pins are for controlling the Radio Shack cassette recorder motor. To get audio, connect the data output to a speaker. Unfortunately, I could only find this ugly surface mounting connector, which does not have a case, but oh well, it will stay in the back of the computer. Finally, the filter capacitors I ordered have arrived. I only managed to find a 0.1 UF as Class X2 capacitor, while the other two small refas, which were 0.22 UF, I think, I took them in polypropylene. It shouldn't be a big problem, as a security measure there is the large 0.1 UF. Locally, on the other hand, I bought other capacitors to replace this jungle of old electrolytes. I wouldn't have done it if I hadn't seen that one of the high voltage ones was bulging and if the power supply didn't make a little strange noise. Okay, I am done repairing and restoring the computer, at least until I find another tube to replace and the exact paint. Before closing the computer, I want to put inside a sheet in which I have marked the date of recap and all the things I have done to this computer, so that if in the future I have problems, I can start from here. Oh, I was forgetting. Since I modified a bank of 4164, I put it on the second row of chips, so now I have 32K on this computer. The original RAM surprisingly works, so I put it back in place. Let's admire how beautiful the Tandy Corporation logo on the ICs is. Well, this is the end, at least for now. All in all, I really enjoyed working on this machine. The technical documentation is a lot and well done, and there are many online communities that keeps these machines alive. Speaking of troubleshooting, I could certainly have found the IC failure by probing it with the oscilloscope. However, I wanted to eliminate every possible variable related to interaction between different chips. It is good to remember here that this is just an hobby for me and I am still a novice in electronics, so it is a miracle for me to be able to make it work. As for the computer, I'm happy to have one of the first specimen, however, since it doesn't have the floppy interface, I can't use TRS-80 and LDOS, and I am therefore limited to the software of the TRS-80 Model 1, and this is a shame, so I'm looking for a modern substitute for that interface, maybe an hard disk emulator, but we will take about this in part 3. I hope you enjoyed following me on this adventure, for which, to tell the truth, I didn't have so much hope. Thanks for watching until the end and see you next time!